So rather than slides, what I have is many tabs. So hello, my name's Glenn. I've been a member of fizzPOP for years. And during my day-to-day work, recently we've ended up doing a side business, well, it's not a side business, basically making equipment for escape rooms. And some of that involves using Arduinos and Raspberry Pis to make physical things actually do the physical bit. So Arduino is a family of microcontrollers, so little tiny computers that can do things. Sometimes you might want to add up some numbers, but usually if you're doing it on a microcontroller, you want something physical to happen. It might be an LED to light up, it might be a door to unlock, it might be the ta-da sound of a congratulations, you've won the escape room. Its origins are in the education sector, so the idea is it's a teaching tool to teach people, or say, I mean, you say children, but it's like, really, it's, you know, it's such a wide range that this can cover, because the microcontrollers that they use are like real microcontrollers that get used in industry. You can start off with blinking an LED and go all the way down the rabbit hole into assembly, blah, 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 blah. So if you were just going to get started, you would need the software and a board. So let's see if this is going to work. So they are the official board. And the idea is that you would plug these into a computer via USB, and you would download the Arduino IDE software, hit the keys until some magic happens, program the Arduino, and then once you unplug the Arduino, as long as it's got power, possibly from a battery, possibly from another power source, it will just keep running that program forever. Which can be handy for things like if you've got color change LEDs where it does a particular pattern and you've got them on your backpack, and rather than having to you know, with something like a Raspberry Pi, it's like massive overkill, uses a lot of power, and really with Raspberry Pi stuff, it tends to be stuff that requires a lot more horsepower, so things like computer vision, or even stuff that like harder networking, like web servers, or even like desktop playing videos, that sort of thing. So if you just only want a device that's going to do something that people will see, but it's not a video, it's just like blinking stuff or a moving thing, Arduino's lower power, can run off batteries depending on the other things that you're powering. But just to give you some idea, an Arduino Nano is about €11, and basically I've got it sorted by price order. So as you go down, it starts to get a bit more expensive. The original, or well, I don't know if it is the original, but the main one it's recommended to start with is the Uno. But because the software is open source, people who work with other microcontrollers have made software to make libraries to make those chips compatible with the Arduino ecosystem. So the code that you would run on a £20 Arduino Uno will also work on a £1 80 tiny 85, which is one of those things where to start off with, you kind of want the hand holding with all the tutorials and stuff. But once you know the pros and cons of what you're buying, you might want to, so for like an 80 tiny type of chip, they cost like £1, £2, and they've got lower power. They'll run forever on a battery, and if you're only just blinking one LED or doing a color change or a pretty little pattern, they can be a better bet. So this is just basically where and how to get the Arduino IDE. And this is like retail, the Uno's £20–25, but if you get a clone from China, it's a lot cheaper, as you can see. One thing to be aware of is that the various clones and varieties, they can either be socketed or non-socketed. If you're going to program a chip that you want to leave in a device, it can be better if you have the socketed chip, because if you blow it up, you can just replace the chip, because you can sell the chips. They sell the chips separately. Or if you're going to have it on a separate board, it's going to be programmed once, and you're just going to leave it there. You can program your chip, put it in the device, and then carry on with your new chip. So this is just me searching for ATtiny85s, just to give you some idea of how much they cost if you wanted to go down that route. The surface mount stuff tends to be cheaper, but that's not necessarily what you would go for to begin with. You'd want something like a 8-pin PDIP. So you can buy the sockets, and you can plug those into. Rewinding slightly, with the ATtiny85s, they don't have USB built into them, so you'd already need to have another device to program it with, which can be an Arduino, or it can be what they call an FTDI chip, like a programmer. So these are like a comparison chart of all the various varieties of ATtiny. Now, because you might notice I'm a bit fond of the ATtiny series. Like as far as RAM goes, you're talking like bytes of memory rather than kilobytes. But if all it's holding in memory is the pattern of 10 LEDs, that's 30 bytes. You don't need you don't need like a megabytes of RAM for that. So this is selling the chip separately. So that's £3–4 quid for the chip on its own. And this is how to program an ATtiny with an Arduino. It's basically the Arduino speaks UART, serial connection, where it just turns one of its legs on and off in the right kind of way that the ATtiny understands. And it's quite handy. One other board that's not Arduino per se, but the first board that I actually owned was a Node MCU, which is a microcontroller with Wi-Fi. So rather than having to have it constantly plugged in, you can, depending on how sophisticated your software setup is, you can reprogram it over Wi-Fi and basically debug it remotely. So once you've got your software and your chip, it's like, okay, now what? There's many different inputs and outputs the Arduino can have. So things like infrared obstacle avoidance sensor. So that might well be on it might be on an analog input where it's reading the intensity of the light that's being reflected, or it might be on one of the digital inputs where there's another chip on here and it's literally just giving a number over the digital input. But I mean, it's like moisture sensors, microphones, temperature sensors, gas sensors. Wow. So as far as digital communication goes, a lot of the other inputs and outputs and peripherals, if they're a bit on the sophisticated side, rather than just say yes or no over the digital pins, there are actually protocols where the chips can communicate with each other. So some are I2C, so like I2C, SPI, and UART is well, they call it the serial. That's basically bit banging the just raising the legs high and low, like we saw with the AT timing. Arduinos can use RFID readers. Now, as far as actual outputs go, once you control an output of a leg high or low, that can then be used to turn on something else. It might be an LED where it's being driven directly, or you might be driving a relay that turns on a washing machine or a lamp or something else. So a stepper motor is a motor that steps. So in the Arduino sort of view, it reads its inputs, it makes a decision as to whether to take another step, and takes another step. So if it is trying to get to, say, position 100, and it's like, okay, take another step. Oh, we're on position 3, and it will just keep looping until it's at position 100. And depending on what inputs you've given it, you can decide what position it should be in. So a H-bridge, see, that's a disadvantage of just using tabs. Everyone is trying to sell you something. H-bridge is a way of driving, using a microcontroller to drive a DC motor, so a direct current motor. So the idea is that there'll be 4 outputs, but because the Arduino can't supply enough current to drive the motors directly, they drive 4 transistors, or MOSFETs in this, power transistors, that create a network that applies voltage and power across a motor in the correct direction, and more sophisticated ones might do it at a variable voltage or variable current in order to control the speed. A servo is a motor that takes a pulse width modulation. I bought it. Pulse width modulation signal as an input. So if the signal is high or low for a certain percentage of the time, that maps to a angle between 0 and 180 degrees usually, and these would be using things like remote control cars or airplanes, or in puppetry, because if you're going to blink, it's like zzz, 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 that sort of thing. So yeah, these are the stepper motors. They come with the driver boards. So because the Arduino can't drive them directly, you would have an input to this board that would have a separate power supply going to it, and those boards are what drive the stepper motor according to what the Arduino tells it to do. One thing to be aware of with these microcontrollers is that they don't all work on the same voltage. So like, for example, an Arduino Uno runs off 5 volts, and all its inputs and outputs are expecting 5 volts. If you try to connect that up directly to a Raspberry Pi, you will kill the pins on the Raspberry Pi, because the pins on the GPIO pins on a Raspberry Pi are expecting 3.3 volts. Now, there are things called level shifters, which can convert backwards and forwards between the voltages. But if you were going to do something quick and dirty, because the 3.3 volt output is over the halfway point of the 3.3 volt output of the Raspberry Pi is over the halfway point of a 5-volt device, you can use a Raspberry Pi to drive a device that's expecting a 5-volt output, but it wouldn't be able to accept anything back from it. So you can drive a 5-volt servo if you're powering it separately off a 3.3-volt signal. So on an Arduino Uno, they have several, 4 or 5, analog to digital converters. So if you need to do, like some of the sensors are, say, for example, a thermistor, you get your temperature from making a measurement of the voltage across the thermistor, and then there would be some calibration, some maths involved to map that to a temperature. But for a Raspberry Pi doesn't have any analog to digital input, so you can buy the chip separately to do it. I mean, one of the things that I've done with an Arduino Uno is that we've had a Raspberry Pi in a prop for the escape rooms, but all of the other props are being driven from the Pi, and it didn't have enough I/O. So what we ended up doing, because it's what we had, I used an Arduino Uno that basically took all the inputs and spat them out to the Pi, and literally no logic was on the actual Uno, but it was reporting what its inputs were. The Pi was working out what it's supposed to happen, and then reporting back and saying, make your outputs this. So I think we gave a demo previously about you can drive one of these LED matrix panels with an Arduino. The two limiting factors are power and RAM, or the 3 limiting factors, power, RAM, processing. So one of the things that I've done before is have like a fake fire animation, and I kind of started running out of RAM. So using an Arduino Uno, I had 2 kilobytes of RAM. So what I ended up doing is making a couple of columns of animation and then copying it, just spitting it out several times and like moving the columns around to make it look like it's not just the same thing copied over and over again. And the DroneBot Workshop is a very good YouTube channel if you're starting out and want to learn more about circuits and Arduino and the programming of them and the doing of the things. So in a previous life, fizzPOP used to hold mini sumo events. We're starting that again. So on at least one of these, you see on the top there, that is an Arduino Uno, and it's running floor following sensors, so it can detect when it goes the boundary between black and white. And well, let's watch. The idea is they've got to push each other out of the ring. So let's start that again. So you can see the logic where it's like, okay, keep going forward until you hit the line, then back up, turn a bit, keep going forward. And eventually they find each other and go, ha ha, and then try and push against each other. There was a, going back to the infrared sensor, there is a thing that we call the protractor, where there's basically 3 infrared distance sensors in an array around the front, and it's sort of like it can detect a field of view. So you end up where you can turn until you can see an object and then run at it. And yeah, that's everything. Oh, no, I'm lying. Because I'm like looking down and going, why is that all there? Oh, right, I was going to show you. So the...
just hear everyone in the background. I thought that was next door.
So this is blink. So it literally, in the code, you set up, during the setup section, you set the on the Arduinos, one of the pins, usually pin 13, has a built-in LED on it. So it knows what the LED built-in is, and you're setting it as an output. And the code basically goes, yeah, turn it on, wait a second, turn it off, wait a second. So if I compile and run that, that is this device.
Ah, okay.
So it's literally blinking on for a second, off for a second. Now the other program that I had open is that, but it just has some output. I just realised you can't. Why are you not? There you go. So it just, when it turns the LED on, it writes, it says LED on back to the computer. When it turns it off, it says LED off. As the light you've got the light that's blinking on and off that we're turning on, but if you look closely, there's another light next to it that flickers slightly. That's the indication that data's being written over the serial connection. And last of all, promise.
I can still hear that video.
So I've got another device plugged into this. And this is an Arduino Nano with an infrared receiver. And I've got an old remote control, and I can do this from across the room. You're like, woo, 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 woo. FFFFFF just means you're holding down the button. Just repeat what the last command was.
Oh, I see.
So if I just press it once, you can see the code, and then hold it down, FFFFF. Right, there we go. Now I'm done.